Section 12.2, Plane Geometric Figures. A polygon is a closed figure that has three or more line segments, also known as sides, that lie in a plane. Some examples are square, rectangle, triangle, hexagon, pentagon, etc. In terms of a regular polygon, each side has the same length and each angle has the same measure. An example would be a square. An isosceles triangle is a triangle in which two sides are equal to each other. Therefore, the angles opposite those sides are also equal. For example, in triangle ABC, you'll notice that segment AC is equal to segment BC. Therefore, angle A is equal to angle B. In an equilateral triangle, all three sides are equal to one another. Therefore, all three angles are equal to one another. So AC equals BC equals AB in terms of the sides, and angle A equals angle B equals angle C. Now, in a situation where you have an equilateral, therefore equal angular triangle, each of the three angles is 60 degrees because the sum of the three angles of a triangle always is 180 degrees. And then finally, we have a scalene triangle. Scalene triangle is one in which no two sides are equal and therefore no two angles are equal. So all three sides are different from one another and all three angles are different from one another. An acute triangle is a triangle in which all three angles are acute. The word acute means less than 90 degrees. So all three angles in this situation are less than 90 degrees each. Now, remember, no matter what the triangle looks like, no matter what type of triangle you're working with, the sum of the three angles is always 180 degrees, 100% of the time. Another type of triangle is an obtuse triangle. An obtuse triangle has exactly one obtuse angle and two acute angles. The word obtuse means greater than 90 degrees. So we have one angle that's greater than 90 degrees and we have two angles that are less than 90 degrees. And then finally we have a right triangle. A right triangle is one in which one angle has exactly 90 degrees, which is also known as a right angle. And the other two angles are acute angles. So again, we have exactly one 90-degree angle, which is also known as a right angle, and we have two acute angles. Let's discuss some perimeter formulas, starting with the perimeter of a triangle. The formula is P equals A plus B plus C, all lowercase except for the P. And if you take a look at my drawing of a triangle, you'll see each side is labeled, one as A, one as B, and one as C. The perimeter is simply the addition of all three sides. In terms of the perimeter of a rectangle, the formula is P equals 2L plus 2W. There are two lengths to a rectangle and there are two widths to a rectangle. So technically the perimeter is L plus W plus L plus W, but you can combine the L's and you can combine the W's. So you end up with 2L plus 2W. And then we have the perimeter of a square. The formula is P equals 4 times S, or 4S. The sides of a square are all equal to one another, so it's technically S plus S plus S plus S, or 4S. Finally, we have what's known as the circumference of a circle. The circumference is technically the perimeter of the circle, or the distance around the circle itself. Notice in my picture I have something labeled as R and something labeled as D. D stands for the diameter. The diameter goes across the entire circle through the center, and the radius is simply half of the diameter. The formula for circumference can be written one of two ways, either as C equals 2 times pi times R, or C equals pi times D. So we have 2 times pi. Pi is a number, it's an irrational number, times whatever the radius is. Or think of it this way. The diameter is twice the radius, so you could also write the circumference as pi times d. So it would be pi, which again is just an irrational number, times whatever the diameter measure is. Pi, as I mentioned, is an irrational number, meaning that it is a non-terminating, non-repeating decimal. The exact value of pi is 3.141592654, etc. What we will use in the formula is that pi is approximately equal to 3.14. In general, pi is equal to a circle's circumference divided by its diameter, or the ratio of a circle's circumference to its diameter. Find the perimeter of number 1, a rectangle with a width of 2/3 feet and a length of 2 feet. Number 2, a rectangle with a length of 2 meters and a width of 0.85 meters. Let's use the formula P equals 2L plus 2W. So for number 1, we have P equals 2 times 2 plus 2 times 2/3. 2 times 2 gives us 4. 2 times 2/3 gives us 4/3. What I did from this point is turned 4 into 12 over 3 so that we had an LCD. 12 over 3 plus 4 over 3 gives us 16 over 3, which converts to a mixed number of 5 1/3 feet. For number 2, P equals 2 times 2 plus 2 times 0.85. So when we multiply, we get 4 plus 1.7, and when we add, we get 5.7 meters. Find the perimeter of number 3, a triangle with sides of lengths 5 inches, 7 inches, and 8 inches. And number 4, a triangle with sides of lengths 12 centimeters, 15 centimeters, and 18 centimeters. Number 3, we're going to use the formula P equals A plus B plus C. So we have 5 plus 7 plus 8. So we have a perimeter of 20 inches. And for number 4, P equals 12 plus 15 plus 18, which is 45 centimeters. Find the circumference of number 1, a circle with a radius of 18 centimeters. Number 2, a circle with a diameter of 6 inches. Number 1, let's use the formula C equals 2 times pi times r. So we have C equals 2 times 3.14 times the radius, which is 18. When we multiply the three numbers together, we get 113.04 centimeters. For number 2, let's use the formula C equals pi times d. So we have C equals 3.14 times the diameter, which is 6. So we end up with 18.84 inches. Let's now find the perimeter of an object known as a composite geometric figure, such as the one that you see here. This composite geometric figure is made up of a rectangle and a semicircle or a half circle. So what we have to do is determine the perimeter or the circumference of each part and add them together. So in terms of the rectangle, the perimeter formula is 2L plus 2W. So 2 times 12 plus 2 times 4, which equals 32. But one of the 4 sides is not part of the original geometric figure. So what we have to do is take the perimeter 32 and subtract 4 from it, which is the dotted side, and we end up with a perimeter of 28. In terms of the semicircle, we can use the circumference formula pi times d, or 3.14 times 4, and we get 12.56, but it's a semicircle, so we have to cut it in half. We only want half of the circumference. So take 12.56 divided by 2, and we end up with 6.28. To determine our entire perimeter, we take 28 plus 6.28, which equals 34.28 meters. Find the perimeter of the following composite geometric figure. We're going to split it into a pentagon and a semicircle. In terms of the pentagon, the perimeter is simply 5 plus 5 plus 5 plus 5, or 5 times 4, which is 20. And the semicircle has a diameter of 7, so pi times d, or 3.14 times 7, we get 21.98. But again, it's a semicircle, so cut it in half and we get 10.99. When we add the two perimeters together, we get 30.99 centimeters. Finally, find the perimeter of the following composite geometric figure. It's part rectangle and part 2 semicircles. So starting with the rectangle, the sides we want to count are the 8 inches. So the perimeter is 8 plus 8, which is 16. Now, in terms of the semicircles, we're going to use pi times d, or 3.14 times the diameter is 3 inches. And we end up with 9.42. Now, normally for a semicircle, you would cut that in half, but because we have two semicircles, it actually forms an entire circle. So we can just use 9.42 for the circumference. And when we add the two numbers together, we end up with a perimeter of 25.42 inches.